Alrighty, happy Monday. It is our first full week, which is feels a little weird because it's like week 3, right? We haven't had a lab yet, but today, today is the day. We'll have so much fun in lab. Sorry, my sugar's a little high right now. It keeps beeping at me here. Um, I also have lots of coffee here. I did not sleep well at night. I actually went to bed early and then woke up and couldn't get back to sleep because, of course, the time I try and get enough sleep so I can get up early and get here on time. My body's like, nope, not gonna happen. So I have a whole pot of coffee. I remember to bring my filters this time so I can make one in the CIS building. So I've got plenty to share if you want it. It's all right. We got lecture, and then we'll have a short break, and we can all walk over to HPEC 1190 for lab, and we'll have fun with lab. So for labs, they're typically not due until the following week, 11:59 p.m. So you've got a whole week plus a couple hours to get it done. The goal with labs is you're done before you walk out that day. But things happen, people get behind, people miss stuff, or you're just fried because you've been sitting and listening to me for more than an hour, and then we're going to go write a bunch of Python code for another hour and a half here, and you're like, I just can't do it anymore. That's okay. Totally understand that happens. Not the end of the world. Um, I went through my entire undergrad and grad school doing night classes where we went like 6 to 10, and I was used to a 4 hour block, and then I tried to go back to it um, in my 30s and sitting for like 3 hours straight listening. It's that's a long time. 3 hours is a lot here. I think my attention span's been broken by my phone here. It's just hard to focus on anything for long periods of time anymore. I can talk for a long period of time, but if I have to sit and listen to someone else for a long period of time, like I start wandering. So um, I get it. I get it. All right. So we're going to pick it up with the next chapter here. Again, there wasn't too much with variables and expressions. There's a lot there, but we can't really do a whole lot with it. It's not very interesting until we get to some more stuff here. So we're going to look at types here, which is a lot of fun. We get types and branching. I don't know if it's going to take us all week to get through types, so I'm hoping we can start branching on Wednesday. We'll see how that goes, because there's a lot to branching we want to practice and get to. And ideally, Wednesday we'll be able to talk about the project for Project Zero. I think that flow will probably work out pretty well because ideally we're going to use branching because it'll make our project much more interesting. So hopefully we've talked about it, a little time to get into it, and then we'll go practice it the following week's lab here. But types are important, so we know how we're storing different kinds of types here. Different ways we can store data in Python is a lot of fun. So do that today. Our lab, I'll go over that before we even get there. I'll sort of end today with what the lab will be, because that way it's recorded on video. I don't record lab sessions because it's just me sitting there. And then if I'm doing something, I'm going over to where your computer is helping you. So there's actually nothing to record on my computer for labs. So there won't be any lab recordings. So if I want to show something for labs, I'll do it in the lecture time. But this is about the only time I'll do something for lab. Usually we just work in the lab, we get the lab assignment done, and then we're done. Occasionally I might talk about the lab the following lecture if there's something like everybody got stuck on. I'll be like, oh, hey, by the way, everybody got stuck on this. Let me make this more clear here. So it's a good gauge for whether or not we absorbed some of the material on Monday. Um, and then we'll wrap up the rest of the chapter on Wednesday. So hopefully it goes pretty well for us. Right. And then in Zybooks here, I'm going to pull up the Zybooks, that's right. Let me pull that up here in a second. I did put the Zybook completion assignments out here in Canvas. So again, we got a little bit of a slow start for chapter 1 and 2. So none of those are due until next week, but also chapter 3 is due next week. So we're going to spend the week on the chapter the following Monday, 11:59 p.m. It's due. So you need to have gone through the chapters in Zybooks, and that includes the Zylabs here. Sorry, let's go to the other class here. So it'll give me a report here. So it looks like half of you folks have gotten the Zylabs done, 61% of the challenge, 64% of the participation. So what I'm going to do, sometime after Monday, 11:59 p.m., I'll go in and run the report, and it says this person's name, this percent complete. This person's name, this percent complete. And I'm just going to go plug those in. They show as 100 points. The points only matter within the category, right? The labs themselves make up 10% of your score, the Zylabs. So just doing the textbook gives you 10% of your grade. It should be free points, right? Given time, you should be able to get all these things in and get them done. Here, we'll look at one of the Zylabs a little bit later today. I'll walk you through it in case you didn't have a chance to look at that here. And I'll show you this is how you go solve it. You can run it as many times as you want, submit as many times as you want here. Okay, so the goal is you get it done. If you're having trouble with it, let me know. Happy to help with these here. But ideally, if you've done the reading, you've watched the lecture here, you should have all the tools you need to get the Xylabs done. They're just annoying because every single space and tab and new line has to match, which is it's a good practice to pay attention to details. Hey, if it says it needs 3 spaces, you got to give it 3 spaces. When it comes to the projects, I'm not that particular. I'm more about can you get the job done, whatever way you find is interesting here, because I think programming is a very creative process here. I'll let you figure out how you want it to look here. It's totally up to you, and we can do it a bunch of different ways, and that's okay. But for Xylabs, it will check letter by letter, space by space, tab by like everything has to match exactly here. All right. So all of those, right? 11:59 p.m. next Monday. Okay. Free points for doing your textbook. All right. So let me go start up a new project here. We'll go to PyCharm. I still need to go install the new version here. I've not yet. I should do that later today. Maybe I'll do that in lab. Again, if you have the new version that's the everything here, go and turn off the pro license. You don't want any of the pro features. I promise you don't need the bells and whistles right now. You don't want it to try and give you code, right? It's not going to be helpful at this point here. So I'm going to go make a new project in my GitHub directory, right? So if I put it in the GitHub directory, GitHub can watch for files to change. That's good. And we'll do this for lab. We'll do this for projects. I'll show you what that looks like here again when we get there. So this is week 3. This is types. And I like this welcome script because it gives me the main Python file. I don't have to make one myself. You're more than welcome to make one yourself, but doing less work is nice. But don't check the create Git box, right? If you're putting your project in a Git repository already, and you put Git inside of Git, it confuses Git, and we all get confused, right? Just it's okay. It's fixable, but it looks really awkward. So here, I'll show you what it looks like. So if you check that box by mistake, I'm going to forget next time and not do it. Let me open up GitHub, and I'll go to our course repository. It's going to look really weird here. So 1501. Give it a second to make the files. Just thinking about it. There it goes. So, oh, it did. It showed me my main file. Usually it doesn't do that. That's interesting. Oh, there it goes. Okay, this is what it usually looks like. So it says week 3 types, but it doesn't show anything. It says it's empty. So if you put a Git repository inside of a Git repository, it's like, I don't really know what to do with this. It's just ugly. So to fix it, we just go to the folder here. So I can right-click the folder in my project view and say open in Explorer or show in Finder in MacLand here. And inside of that folder, we'll see a hidden Git folder. So if you don't see hidden files, you go to View, Show. You always want to have your file extensions and hidden items checked for developers. That's just pretty helpful to be able to see these things here. So if you don't see it, just make sure you check the hidden items. I can delete the inner .git folder. I don't want to delete the one from my repository. That'll make me really sad because I'll lose everything. I can delete the one from within that folder here. I don't want that one. So if I get rid of that, it's removed Git, right? The .git folder is where all the Git magic happens. If you get rid of it, there's no Git magic. And now PyCharm says, oh, hey, there's a bunch of new stuff here. So yay, this is good, right? We want all the stuff. The main py file is the important one. The rest of it just makes it so we can open it up with PyCharm the next time you come back to it. So there's anything in the .idea folder, just let it happen. Okay, no worries if it changes or not. So I can say week 3 started. Again, commits are free. Don't worry about the electricity charge. It's minor, right? To get it out to the data center somewhere. That's okay. Commit early and often, because once we commit, our repository has it on our computer, but then we need to push to get it to the cloud. Git is a push and pull system. So we're going to push that out to the cloud. Once I've pushed, I've got it out in the cloud. I can go view it on GitHub to make sure. That's my little sanity check. Do I see my week 3 types here? Yeah, I see the folder. I see my main py file. I see the code I expect. It's just the starter template code. I made it, right? So if you can see it on github.com, I'll be able to see it on github.com. That's your good little sanity check here. Okay, so we made it out there. Life is good so far. And now we can start. Again, I always hit run just from here just to see if it works. Hi, PyCharm, life is good. It runs. We found the right Python environment. Life is good. I'll delete that starter template because I don't particularly care. Right. All right. So we're off to the races here. So chapter 3, types. There's a bunch of things when it comes to types here. Python lets us do lots of really cool things here, but we're going to use some interesting ways here. And types are just ways of storing data. So strings, we can store strings. Strings are just a bunch of characters here. It could actually be empty. It could be no characters at all, right? An empty quote is still a string. a bunch of one character, a bunch of characters, that's all fine. You can do cool stuff with formatting. We'll look at lists and tuples or tuples. We'll look at sets and dictionaries, conversions, binary numbers. Did we do a little bit with binary last week, counting by powers of 2 briefly? Works the same way here, same idea. I got ahead of myself, I guess, here. And then we got a couple labs to practice it here, which is a lot of fun. Okay, so when it comes to strings, right, that's a string, right, just a bunch of characters here. We could do some cool stuff with it here. What we get to do is pick individual characters out. So if I can have like a string for name is an input of enter your name, right? We can ask them to enter their name here. And then fun things that we can do, because it's going to store the individual characters, I can say, I don't know, the first letter, we'll print first letter of your name is. Now, one thing you want to note here is it always starts at counting 0, position 0. So the first item is at position 0 or index 0, and then index 1, 2, 3, 4, 5. So we're going to get used to starting at 0. That's how we count. We always start with 0 when we start counting. If you are also taking R, it doesn't start at 0 because it was written by math people, and they don't understand that you start counting at 0 for some reason. I think math people don't think 0 is a number. Isn't that what math people say? It's not actually a number or something like that. I don't understand a lot of math. It's okay. So to get the first letter of my name here, it's going to be name, and then I use the square braces. So square braces are essentially we're saying index of. So name index of 0 here, name at position 0 at index 0 here. So when I run it, it says enter your name. I can put in Eric, and I get the first letter of your name is E. Life is good. Now, what happens though if I just hit enter, my program crashes. It says string index out of range. If I didn't give it a name, an empty string is still a string. Right? It's just there's nothing in it here, and there is nothing at position 0 because I didn't give it any letters, and my program crashes. Dealing with bad user input is something we'll learn to tackle later. For now, we're going to assume the input's good. If I ask for something, assume they can gave me the right thing, which is a real bad assumption in the real world. But for now, we just don't know how to do any better. So we're just going to assume they give us the right thing here. So we got name, and we can get individual characters out. You can get the length of it here, which is really nice. So how many characters are in your name here? So we can print, there are, oh my goodness, there are, and then I want the length of name. So it's LEN, short for length. I don't know why they didn't spell it all out, but sure, length. Letters in your name. Now, remember, when we comma separate, we get these spaces automatically. So a lot of times in Xylabs, if they're particular about spaces, if you comma separated your prints, you got extra spaces. If you don't want the commas, right, or if you don't want the spaces in there, you have to concatenate yourself. So we can say R plus the length here and plus this one here, but then length is an integer and it needs to be a string, so we have to convert that to a string. So we can say the string version of the length of the name. A little bit wordy here, but that's okay. We'll stick that all together here, but then we have no spaces. So I put in Eric, and we get, when we comma separate, we get the spaces. When we don't comma separate, we don't get the spaces. So I have to add them in myself here if I want them. Again, so like if you want to add in like dollar signs and things like that, and you want them to touch, you can't use the comma separating because when you comma separate, it'll put a space there. And be like, I want the dollar sign to touch my number. Well, then don't use the comma. Right? Just some different ways of going about it here. Both ways work here. So if I know how many letters are in my name here, right, I can also give you the last letter of your name. Last letter of your name is, and then, oh, I don't need 2 spaces, do I? There we go. Don't need that one. So name, then index of the length of name minus 1. Right? If Eric has 4 letters, there is no index 4, right? Because it's 0, 1, 2, 3. No 4. So the length minus 1 is the last character, the last position, right? That gets to be fun. So enter your name, Eric. I see the first letter, the last letter, on and on and on. It'd be nice to get all of them. We just haven't got there yet. It's okay. Not the end of the world. Now, this sort of, you want the last item here is super common. So you can get a piece of that string here if you want. So I'm going to say, hey, I want just repeat this again here, last letter of your name. But instead of saying the length minus 1, I'm just going to say I want the index of minus 1. So you can count backwards from your indexes. So take the last index minus 1. So minus 1 is the last item, minus 2 is the second to last, minus 3 is the third to last, on and on and on, right? We can go all the way backwards here. So we get the same output here by saying I want minus 1. It's essentially like the length is implicit here. It's length minus one. We just minus one. Python knows what we wanted, which is really cool. Python has all sorts of fun, handy shortcuts to make our life easier. Okay. So we can get out individual characters. Now, just because I can get an individual character doesn't mean I can change an individual character, right? I can't say name index of 0 equals a, right? It's going to yell at me here, and it's even warning me right now. It says class string does not define set item, so the square brace operator cannot be used on its instances. That's a big wordy thing for you can't do that. You can't go change individual characters. You can get them out here for reading, but you can't set them. So we can get, but we can't set here. So I try and run it. So Eric, it crashes on me. It says string object does not support item assignment. Not the most helpful error in the world here, but again, you can't assign an individual item of the string. Okay, just a little warning here. So we can't change. Can only read, not change individual letters. Right, so I'm going to leave that commented out so our program doesn't crash. Is that okay? Oops. And take out my breakpoint. Okay, so we can do some fun stuff there with our strings. Um, that's the brackets, right? The indexes here. We did indexes, creating our string variable. Good, we did that. Now you can change the value of name, right? But we can't change an individual letter. So if I wanted to change name, then we can say name equals, we'll go say Bob instead. Perfectly fine, right? You can change the entire name, change the entire string. Well, you can't change individual letters. So what this does behind the scenes, for those of you who like the fun stuff behind the scenes, is it goes out to your operating system and says, hey, I need a place to store Bob, which is 3 characters, right? Give me the space to store 3 characters somewhere in memory. It's a new location in memory. And it says name, you don't point to over here anymore where Eric was stored. You point to here where Bob was stored. So we've changed where string is looking here, and eventually the memory that was used to store Eric gets freed up by our operating system. Python says, I don't need it anymore. You can have it back. Here, that's called garbage collection. A whole other thing we'll get to it later. Yeah.
So now when you use name before Bob and use whatever here, but then after like the little Bob, it will use Bob.
Yep. Yeah. So name what is whatever I've stored in memory there. So it was whatever the user typed in. Now it happens to be Bob. Right. So when I print name, now we get Bob out. Eric. Oh goodness, why is that? There it is. So we'll get Bob because we've changed what name is looking at, right? Variables just say, hey, here's where I've stored something in memory. That's all the variable is, right? It's just pointing somewhere. So it allows us to put a name to what we're storing, which is nice. So you can change them if you want. All right, cool. String formatting. Lots of fun things with string formatting here. F strings are fantastic. Here, these are formatted string literals. So this is a nice, easy way to go through and get some output, or really just any sort of formatted string here. So having to comma separate, and then like here's a quote here, and here's something that's code, and here's another literal, gets to be a little bit annoying here. So what the fine folks at Python and other programming languages have given us is a way to string interpolation. It's a really fancy word here. I love saying it because I like fancy words. String interpolation. So I can print, and now all in quotes here, I'm going to put a little F here to tell Python, hey, I want to format this string here. I want to do some string interpolation. So the entire thing gets to be in a string. So the first letter in Bob's name is, oops, if I want to use a apostrophe here, I should put my whole quote in, or my whole literal in double quotes, right? Or I could escape it with that backslash character. Either way works here. I'm lazy. I don't like my backslashes. So I don't need to comma separate here. I just, inside of the string, I put a set of curly braces. I don't know why curly braces, but we're going to use curly braces here. So that's the shift square brace here. And inside of curly braces, now I get to put code. So I put name index of 0 here, right inside this string. So I don't have to end my string literal. I just put my code right inside of it. So instead of saying, here's this comma and this thing over here, right, I just put it right inside the string as a string format. This one's not that much nicer here, but when we say like there are this many letters in your name, not having to put it, comma separate and change this here, and then I don't have to worry about my spaces because I just literally put whatever spaces I want here, right? So if I put a space after the curly brace, I get a space. If I don't want a space after the curly brace, I just let it touch the curly brace, right? Works out really nice here for getting this sort of formatted output. Eric, and then we get 3 letters in Bob, first letter's B, right? So the string interpolation, the formatted string is really nice. And then other cool things it can do, if we're doing anything with arithmetic and dealing with numbers, we can format those numbers. So we can have What do we want? So some sort of output. So we're going to print a formatted string for 1 divided by 3 is, and then in my curly braces, 1 divided by 3. Okay? So 1/3 here is really long. We probably don't want all those decimal places, right? So if we want to format it here, please don't memorize this. Just go look it up anytime. It's really not worth your brain power, but for some reason I know it here because I do it all the time. Put a colon in it and say, hey, I want to format the thing I just put in my curly braces. Okay. And then I want a decimal place and I want 2 digits after the decimal place for this floating point number. So 0.2f means 2 decimal places in your floating point number. Please don't memorize it. Again, just go look it up. You can Google that anytime you want. How do you format a string in Python? Okay. Not worth your brain power. Just know that you can. Okay. And now it gives me just 2 decimal places after the floating point, which is really nice. Now, yeah,
Set by default, set round up, round down.
it will round. Yes. So round the regular rounding rule. So if you do 1/2 here and we round, we get 0.50. Right? We still get 2 decimal places here. Hasn't rounded up if I want just 1 decimal place here. Eric, we get 0.5. Still okay here. If we want no decimal places, does that even work? I don't even know if that works here. Ooh, it rounded to 0. I feel like it should have rounded up. 5 should round up. Okay, hang on. Let's do another number here. Let's do like 7/8 here with 2 decimal places. I'll show you how it rounds up here. I think doing half was just a bad thing here. Okay, 0.88. If we go 4 decimal places, right, we see 0.875. So it does round. It should round. I don't know why we got the 0. That one's a little weird, but rounding half was probably a bad idea. Yeah, so it'll round at that decimal place here, the last one for us here. So we should put it, will round at the last decimal. Okay, does that make sense? So we can format our floating point numbers if we want here, which is really nice if we're doing any sort of arithmetic. We want our output to look pretty, those sorts of things here. Once you start like figuring out how much tax you pay, you probably don't always pay a 10% tax, like an 11% tax of anything. You're going to get all sorts of decimal places. So we should probably round, that sort of thing. Okay. So we can do our string interpolation. Our string formatting is really nice. So replacement characters, yeah, other sorts of outputs, fun. Just go look it up, right? So strings are the default here. Decimals is for integer values. So D integers, not I for integers. Again, I didn't come up with it. My apologies. But it gives you that. If you want the digit separator, I think D for digit makes a lot more sense to me here. I want the digits. I don't. Comma D gives you your comma separated values, which is nice here. You can get leading zeros if you want here. So I want some number of zeros to start here, which is nice. So I can have that notation here. Binary values, so I can convert an integer to binary really easily in Python by telling it, hey, I want it in B here. X for hexadecimal representation is our base 16. You won't worry about this till you get to 310. You can do all sorts of things in hexadecimal. Exponential notation, sure. F, our floating point, fixed point notation, our floating point numbers. And then the precision here and comma dot, you can get your comma separated values in here if you want, which is nice. So you got some fun options as we go. All right. Sorry, I gotta plug in here. My phone did not charge well last night, and I don't want it to die. I just remembered. All right, here we go. Forgot to do that earlier. All right, so ways we can format our numbers, which is nice here. All sorts of fun output. Um, Usually I don't read you the Zybooks here, sorry, but these ones are a little bit particular. Now, lists are a lot of fun. So a list is a way of storing a list of data, right? So we can make some list here. And then for lists, we use square braces, and we comma separate the values inside them here. So shout out a couple things to me. I'll add them to my list.
Cats.
Cats. Okay. Chairs. Okay. What else?
Horse.
Cars. Okay. Give me one more.
Tail.
Ceiling. Ceiling? C-I-E? I before E,
Yeah.
except after C. I hate English. There's a, yeah. Anyway, All right, so we have a list. So some list then lets us store multiple values, and we get at them by index. So some list at 0 then is cats, right? When we ask for it. So if I print out some list of 0 here, we're going to get the first item here, which is cats, right? Just like with strings. Strings is a list of characters, right? A list is just a bunch of things, right? A string just happens to be only characters. So we can go list to 0. We can do, hey, I want, the third thing or the last one. I can print some list, the last item, right, with -1, our shortcut here. We can do that. We'll get our out the ceiling then. But what's cool with lists is you can change it. I can say, hey, some list at 0. Let's assign it a new value. So I'm sorry, some list at, or let's go index 1. Let's replace chairs. So instead of chairs, we want to have coffee. Okay. And then you can actually print an entire list here. So we can print the list and it will give us just what it looks like in our code here. The square braces, comma separated values here. So now I have cats, coffee. Those are all C words. How do we do that? Do you guys do that on purpose? Wow, that's fun. So I got my list here of items and I can change it. So lists are mutable. So this is a mutable, changeable, changeable list of values. Is it changeable? Really? Okay, sure. I don't know when sometimes you have the E or not. Now, other cool things you can do with lists, you can add to it. So I can say some list.append. So some list is my variable. .append says, please go add something to it. So let's add another value to it here. We need another C word now. Cookies. Let's add cookies. And I can print my sum list. Okay. So the list is mutable. You can add to it. You can even remove from it here. So I can take my sum list and I can call remove. And I want to remove, don't remove coffee, I'll be sad. Let's remove cars. Okay. And then we'll print sum list. So we can add to it, we can remove from it, right? Which is really nice. So we've got some quick operations we can do with lists here. Now you can also remove things by position. So you can take some list and you can say pop. Pop takes an index, right? And just hovering over it says it supports index. So the pop of an index here. So let's pop out. Let's see. Let's do the last one. So let's pop out index. Oh, sorry, 3. Right. Pop 3. And we'll get rid of cookies. Oh, we just added cookies. We want to keep cookies. Let's get rid of, not cats. I like cats. I'll just remove cookies. That's fine. So we popped 3. Oh, no, I'm sorry. What did we get here? Cookies. Oh, I didn't print it. Shoot, print some list. One more print here. And then we see we removed the cookies. Now let's remove the ceiling here. We don't need a ceiling. So we change that. We'll remove that one. Now we're left with cats, coffees, and cookies. Life is good. Okay. The cats will want the cookies. Cats don't want your coffee. I guess if you put a lot of cream in it, maybe they'll try it. But all right, so we can remove by index. This removes by index. This removes by value. Now, the fun thing with lists here is you can have the same thing twice. So I'll take my sum list, append cars here. You can have duplicates. Duplicates are okay. So we're going to add in cars, and we have cars twice here. So cars and cars. And when we call remove cars, it only removes the first instance that it finds. So it found the first cars and got rid of it and said, okay, I did my job, I'm done, and gave up. It's kind of lazy. Like us, it's okay. So removing all of them would take a little bit more work. We'll get to how we can do that later. Now, other things that happen, though, if we try and remove something that doesn't exist, some list, remove cars, right, capital cars here, we get a program crashes. List remove X not in list. Now, X is a little bit silly because X was cars here, but saying it crashed because it couldn't remove it. So we're sad. So our program didn't go very well. So you can't remove something that doesn't exist, and Python gets really upset about that here. And remember, uppercase letters are different than lowercase letters because they're stored differently, right? The uppercase C is like 68 or 72 or something, and no, 2 less, it's 67. It's capital A 65, or who knows why. So you can't remove items that don't exist. So I'm going to leave that commented out here so it doesn't crash our program. And then you can also some list pop. If you just pop here, this removes the last item. So So without a number here, it assumes it's the last thing you want to get rid of here, right? So we removed our, oh, no,
Right.
what? Gotta print it. There we go. Thank you. Gotta print it. There we go. Now we got rid of cars again. We got rid of the cars here, removing that last item. So if you give it an index, it'll remove that index. If you don't give it an index, it removes the last thing. Append adds to the end here. You can add something in the middle if you want. So I can take my sum list, you say insert. So insert says what index and what value. So I want to become the new index 1 here. That'll put it in between cats and coffee, right? To become the new index 1, everything else shifts down here to make room for it. Okay, so let's insert at index 1. What should we add in here? A computer. All right, so we'll put a computer on our list and we'll print some list. Right? Because it's a list, the order matters here. Right? So we maintain our order. Everything is done by index here. So it becomes the new index. So inserts it, inserts the new item, become the requested index. Okay, so you can put it at index 0 to be the first item, index 1 to be the second, on and on and on here. Now, if we say like, hey, I want to become the new index 5, and we don't have 5 things here, it just adds it at the end. It's like, oh, sure, but we didn't have 5, how about 4? Or 3, actually, right? 0, 1, 2, 3. So it's okay. Weirdly, that one doesn't crash. Okay, so I'll leave that one here as 1, but it does some weird stuff. So with our lists, we do cool stuff here. Let's see if we got it all. Lists. Oh, the other silly thing you can do with lists here is you don't have to have all the same types here. So I can take my sum list and I can append a 20. Or I can take my sum list. Oh my goodness, sum list. There we go. Append a 4.2, right? And I can print my sum list. I might have had too much coffee. I'm starting to get twitchy. So they don't have to be the same type here, which is different than a lot of other languages, how they work here. So Python lets you stick anything you want in a list. Now it starts to get silly here. If you want, you can put a list inside of a list. So I can take some list and I can append another list of like 1, 2, 3. This is called a two-dimensional list, a list of lists here. Now, I don't recommend this. We'll get to this eventually here, where we'll work on these sorts of things. But if you put a list inside of a list, Python's like, oh, sure, you gave me something to put in the list. It just happened to be another list. It gets to be a little weird here. It's a little weird with lists inside of lists. We'll start doing this later once we've practiced more here, but for now, we'll just ignore it. Probably not what we want to do. Okay, but Python lets you do it. Accessing the elements, we did that. Updating, yeah, we did updates here. Adding, removing, we did that. Other things, you can get the length of a list. How many items in the list? Just like we did with the length of a string, works out. You can take two lists, smush them together. This list plus this list. Sure, doable. You can get the smallest item in a list. That's really fun here. So let's print out the min of some list here. What's the smallest item in the list here? Oh, well, less than not supported between instances of int and string. The list lets us put integers and strings in, but once we've mixed and matched, it doesn't know how to compare and say which one is the least. It's like, hey, you got strings, you got numbers. I don't know what you mean by the least. What's the minimum? I don't know. So if we tend not to do that, if we go back before we did that here, we can get a minimum out here. The minimum value in this list is cats. It sorts them alphabetically, right? And it gives you the first one, right? So it compares the first letter of each thing. If they're the same, compares the second letter of each thing. Which one is least? It's converting to the numeric value, the Unicode value, and seeing which one is least. So capital letters are always less than lowercase letters, which gets to be a little bit weird. So sorting gets to be upward if you're mixing your casing. But other than that, it works out kind of well. Or if you have a list of numeric values, it'll pretty quickly give us, hey, here's the smallest number in that list here, which is nice. So I might have a list of grades then. Grades is a list. I can start with an empty list. And I'm going to ask the user, so I'm going to say grades append an int of an input of enter a grade here. And let's just add a bunch of them here. So let's add like, I don't know, 4 grades. That's probably enough here. We'll print, and we'll do a formatted string. The lowest grade is, and then in my curly braces, I'll take the min of my grades here, grades with an S. And then we'll do maybe the highest grade. You can do a max of that. And how about, let me do paste in again here, the average. Now there is no average function. I don't know what average, no, that's not what we want here. So we'd have to take the sum of the grades divided by the length of grades. So it can sum all the numbers up for us and then divide by the length. It gives us the average here, which is nice. So we should call that the mean, right? That's a better word here, right? Um, Median gets to be a little bit harder here. We'd have to know how many there are and find the middle. We could do it if we wanted to. Maybe we'll tackle that. Would that be fun? Okay. So to find the median, we need to know how many numbers there are, right? So the total grades, or what items, total number of grades is the length of grades. So I know it's going to be 4, which is okay, but it might vary. It might be a different number here. So 4 will be my length of grades. So then the middle index is not just the number of grades though, right? Because, or I'm sorry, not just half of that. That's not going to work out well for us because if I have an even number, right, I need between the two. It's not going to work very well. So I need to find the 2 on either side, right? Um, so actually, we'll give it a second. So let's see if my number of grades. We don't know how to do that yet. Shoot, we didn't get to that. Hmm. So my middle index then, number of grades divided by grades divided by 2. Yeah, we didn't get to. I don't know if we know enough yet to get to the actual middle here. That's a bummer. I don't want index 2, right? If I have 5, it would work here. Let's add one more here, just for fun. So if we have 5, this will be 2.5, which is okay, but we don't. There is no index half, right? So we can't say the index of 2.5. We can only give it whole numbers here. So it turns out there's an operator in Python to give you the whole number division. Drop the remainder. That's the double divide here, or integer division here. So integer result only drops the decimal. So this number, floor divided by integer division by 2, will give us 2, which actually is the middle here. So if we have an odd number, this is good. If you have an even number, it's not going to do anything different, right? 4 divided by 2 is still 2, but we don't want that index. But again, we haven't really got there yet here. So now we can get the middle index, and we'll print out the um, this here median. Median value is. Now, the problem is I don't know what order these grades are in. Right? It's not in sorted order right now. So if I want them in sorted order, I can do that. I can take grades.sorted. I'm sorry, sorted grades at index of middle index. So sorted will go and sort this list here for me, and then I'm going to get the middle index out of that sorted list, which is really nice here. Okay, and I can print out grades. Now, one fun thing about sorted makes a new list here. There's also a sort option here. So I could take grades and I could say .sort, and then I have grades. Sort will change the grades. Sorted makes a new list here. So it doesn't change the order. So it depends on what you want to do here. So let's do name, Eric. All right, so enter some grades here. And these should be numeric values. What scores do we have so far?
85.
85? 93? 14. Ooh, ouch. 56?
72.
72. Right? So lowest grade's 14, highest grade's 93, mean 72, mean 64, median 72, low, low, mid, high, high. Yeah, looks correct. Here's the original version here, and here's the version after we've sorted it. Right? So if the order matters, we don't want to call sort because it will change our order. So this will change, pound sign, here we go, changes the order in the list here. So does that make sense, making a new list versus changing it? So if the order mattered, because I knew, hey, for student 1, this was their score, student 2, this was their score, if I go and sort them, you're probably going to be upset with me because I gave you someone else's grade, right? So again, just working on how we want to do here. Either way, they can both be useful, just depends on what we want to do with it here. Okay, so we got a bunch of values, which is fun here. It turns out Python's halfway decent at arithmetic here. We haven't next week when we get to branching, we'll look at how we can figure out the median of an even numbered list here. We just don't know enough Python yet, and I don't want to jump too far ahead. Is that okay? So we'll just assume this only works with odd. Complete with odd for now, and we're sad. Okay, so we're sad about that. All right, so lists, the sum, the max, you can get specific indexes of a given value or count how many times something occurs. Other cool things you can do. So I can say, hey, what index is this value at? Sure. Or how many times has this one occurred? Which is fun too. Um, so now let's see, we don't have any duplicates. We could add a bunch of duplicates. That one's not all that exciting here. Our cars. So when we had cars, we give us the first index of cars if we asked for it. When we asked for index here, that's the first index who matches. Just like remove, only remove the first one. Cool. Tuples are like lists, but they're not mutable. So tuples are tuples here. Tuples are not mutable. So it looks like a list here. So here's some tuple. And give me a couple values here.
5.
5.
2.
Sure. Strings. Phone. Okay. That's a couple items here. That's probably close enough here. So looks like a list here. Uh, Still a collection where order matters. Okay. So I can still say print some tuple index of 0, get out the first thing, but I can't say some tuple index of 0, change the value to 42. Just like a string, it doesn't support item assignment. That's the same error we got. So strings are actually more like tuples than they are lists, right? They're not really mutable here. They're not changeable here. So you can't assign, you can't change individual values. Individual values. But we can get individual values back out here. So depending on what we're doing here, that can be helpful, right? So we get index of 0 was 5. Right, very exciting. We got our 5 back out, the first thing. We can get the last thing out with -1. You can get, any sort of thing here. You can ask for the length of them. Like all those other things we've done, you just can't go and change them here, which is fun. Now, a set is like sort of like a list, but it's unordered here. And it only allows one at a time. You can't have duplicates. That's why a set, right? You can't have more than one. So to make a set, we'll have some set here is a set of, and you give it, the weird thing, you give it like a list syntax. You say, I want to make a set out of this list here. So we'll give it a list of 1, 2, and 3. And then some set dot, I can remove an item. I can pop an item out by index. I can go and add an item. It's not append because there's no order, right? I can add something to the set, but it doesn't guarantee it's at the end here. Why does it not like set here? What's it bad about? Set literal. Oh, there we go. A set literal. Oh, okay. So the other syntax is curly braces. We'll get to that in a minute here. That's okay. So some set dot, let's add, how about 5? We can print some set 5. So we get our set back out. So we get the curly braces here this way. So you can, I don't know, the line doesn't bother me too much. It's going to bother me a little, but that's okay. So this is unique items only. So if I try and go add something here, some set, let's add 3. Nothing happened, right? It didn't do anything here. So it lets you try and add it here. Allows, adds, or I should say, like it doesn't crash. Doesn't crash. Doesn't change the set. It's given a duplicate. So you try and add something that already exists. It's like, sure, right? No change. Nothing happens here. Some set dot remove. We can remove the item 3 here. And we get it without a 3, right? Like we'd expect. So it works out pretty well. You just make sure we don't have duplicates here, which is nice. Adding and removing, yeah, we did that. Pop it out here. You can update. So you add all of the set 2 into the set. That one's kind of awkward here. That's okay. Other fun things we can do with sets, and this is more math theory. If you got any further math, you can get the intersection of sets, you can get the union of sets, the differences of sets, and the symmetric difference of sets. That's a lot of fun. You can go try them later. It's okay. We're not going to do too much with sets. They're interesting, but we won't do a whole lot with them here. Um, those ones are fun. All right. Next type. Man, this is a lot. We're doing all sorts of fun types here. We get a dictionary. Now, a dictionary is probably one of the most widely used types in Python because it's super cool, does a lot of fun stuff with us. Um, a dictionary allows you to have a key and an associated value. Like a dictionary, here's a word, and the value associated with it is its definition. And now, it's also like a set. You can't have the same key twice. You have the word once in a dictionary. It might have multiple definitions, but the word is only there once, right? So the keys act like a set, but the values associated, you can have any sort of duplicate you want. It doesn't matter here, right? We have lots of words with the same meaning because English is stupid, right? Definitions can match, but you can only have the same word in there once. So the dictionary gives us the curly braces here. So this is some dictionary is curly braces. That's the shift square braces key. So the dictionary, what we're going to do is we're going to give it key value pairs here. So this is key value pairs of key colon value. So maybe we want to put a name and an associated grade here. So we'll have Eric and then colon my grade here. Of course, I have 100% because I'm grading myself, right? Sure, that works out easy. And then we'll add Jeb to the class. I try and get him to watch my YouTube videos. My 17-year-old son, he followed along for like a couple weeks. Then he's like, Dad, this is boring. It's kind of depressing, but that's okay. So if he's watching now, he'll be in trouble. So he gave up after a while. So he probably only has like an 85 or so right now. And then my daughter Journey, she's 15, trying to get her into it here. She's sort of interested, um, not so much here. She's turned in some of the work, so we'll give her a 90 here. So we have key colon value. So again, it's a set of keys, so it's unordered here with associated values. Now, this is where dictionaries get crazy because we're going to use the same syntax for adding and updating. Right? Remember, we could add something as a duplicate. It didn't care. So I can say, hey, some dictionary, let's go add. And to add now, we use the square braces again. So with dictionaries, it's dictionary key of. With lists, it's index of. If we're like trying to say what we would say in English here. So it's dictionary key of. And let's say, hey, let's go add Vivi to my class here. So she's 16. She does not care about computers at all, aside from that they play Netflix, which is okay. She's more of an artsy type. So dictionary key of Vivi, let's assign a value of, let's give her a 75. This will go and add here. Now, I can use this exact same syntax to go and update here. So this will be an update. So if the key exists, then let's say, hey, Journey turned in some more work here. Let's give her a 95. Now, it will go and update the value associated with this key. If the key doesn't exist, it adds it. If it does exist, it updates it. So this same syntax does both. And this is where it gets really weird with dictionaries, right? So if it exists, it updates. If it doesn't exist, it adds. Right? No worries here. And then we can print out some dictionary and give it a run. Eric, 1, 2, 3, 4, 5. And we get out just like it looks like when I put it in, right? Key colon value, comma, key colon value, comma, key colon value, comma. Other fun things you can do with dictionaries is you can get just the keys out. So I can print some dictionary, dictionary dot keys. So the keys gives you the keys, right? Here's the list of keys in that dictionary. Now, it looks sort of like a list here, but it's actually a dictionary keys. This dict keys is a dictionary keys. It's a different kind of object in Python. Don't worry too much about it, but it's not actually a list. Okay, for anybody who's keeping track here. But I'll get the keys out, right? You could also get the values out. Some dictionary dot values, right? I'll get a list of values out or a dictionary values here, right? 5. Here's the values. Okay, so we can get out the keys, we can get out the values. You can get out the items, the pairs themselves here. So print some dictionary dot items. It gives you the key value pairs as essentially a list. Not really a list here, but that's okay. We'll print those out here. I wish you would keep the zoom here. So the dictionary items looks like a list of tuples. Here's the key as the first item. Here's the value as the second item. Here's the key as the first item. Here's the value as the second item. So you get a bunch of tuples here of key value pairs in a tuple form. Sure. Why is this useful? It's not yet. We'll get there to where it becomes useful. Okay. But we can do fun things with dictionaries. So key colon values here, and they love sports and other things here. So here's our caffeine content. Dark chocolate coated coffee beans, 800. Wow, I want some dark chocolate coated coffee beans. They have a lot of caffeine. Buzz Bites chocolate chew, 1,600 milligrams. That's like dangerous, isn't it? What's the uh, um, how much caffeine can you have before getting sick? Let's see. What's a dangerous level of caffeine? 400 milligrams. Two or three 12-ounce cups of coffee? No way. I drink way more than that. Caffeine overdose? Okay. What are symptoms? Abdominal pain, seizures, blood acid levels, fast heartbeat. Okay. I don't have any of those. I'm okay. I'm most of my way through my pot of coffee from this morning, which is not my first coffee of the day. So we think we can have those. Anyway, you give it key value pairs, right? Have as much as you want, which is great. You can get out individual items here, right? Oh, wait, that's the other thing I didn't do yet. Sorry. So if you want to get the value associated with an item here, so we did an add, we did an update. It also does a read. So it reads the value. So we can print some dictionary key of journey. Gives me the value associated with the key journey. So this gets the value associated with the key. So a third way of using this syntax. So this reads it, this updates it, this adds it. Right? All with using the exact same syntax here. It just depends what we're doing, whether or not we're assigning something to it. If it's an add or update, or if we're just using it, it's just going to go read the value out, which is fun. Excuse me. Um, updates. Delete. Some people use the del keyword. I've never seen anybody do it before. That's really ugly. But if you want to remove someone from the dictionary, you can say del some dictionary. I'm sorry. Some dictionary key of, let's remove me from the class. I probably shouldn't be in there. That syntax is super weird. So usually you say some dictionary dot, what is it here? Pop. And it will pop out the key of Eric. Okay. This is the more common way. I've never seen anyone use del here. But technically it works here. And I can print my some dictionary. So if you remove me from it, it should look like we expect, but just me not in it. And here's me not in the dictionary. We popped it out here. So pop doesn't work by index. It works by value in dictionaries, by index in lists. It's super weird why we use the same words for it all the time here. I don't know why. Pop finds a key with the given value. So not by index like it is with lists. All these things are awkward and confusing. Eventually we'll use it often enough, and it's helpful if you just kind of click on it, hover over. It'll tell you what you need to do, right? This gives you the IntelliSense, the documentation for pop. Sorry, it's super tiny on the screen here. Pop removes specified key, returns the corresponding value. If key's not found, returns the default if given, otherwise raises a key error. So if I don't have Eric in the dictionary, it crashes. Like lowercase e Eric, it doesn't match, and it crashes with a key error. Right? Key error, Eric. Not the most helpful error, but essentially at line 136, it didn't find the key of Eric. Right? Couldn't pop it off because it didn't exist. That's all. All right, modifying, cool. Common data types, ints and floats, sequence types, where order matters, mapping types, a dictionary, right? Key associated value here. And then sets are essentially a dictionary without values, is why you could use that other set syntax that it told us about here. When it said, hey, you could use the set syntax, we could say some other set equals square braces or curly braces 1, 2, 3. It looks like a dictionary without values, right? It's just the keys, which that's all a set is. It's just keys, no values. That's why you can use the same syntax here. So behind the scenes, it really is like the same thing. Oh, it's kind of cool. All right, so that's our types here. All right, awesome. We did pretty good, actually. We got through most of the chapter. Type convert, so converting from one type, so we had to do that string of something before. We've done an int of an input. That's doing conversions here. And then binary numbers, not too much worry there. This is good. So we get to branching on Wednesday, but the lab, we're just going to focus on GitHub. So we got about 15 minutes or so to talk about the lab. Is that okay? All right, awesome. So let me go. So I use this GitHub Classroom tool because it will make a private repository that you have access to and I have access to. If you make a public repository, I'll have access, but then so will your classmates. And if two people turn in the same code, I look at both of you funny. Like you probably are cheating, right? So let's not make public repositories. So this tool will do that for us, which is really nice. So I'll go make a new classroom in my Chernesky org, CIS 1501, fall 2025. And then I don't use any of the other features that it has. It does a bunch of other cool stuff, but I just let it create the repository. So CIS 1501, 2025, here is lab 0. Okay, so for lab 0, I need my Python template here. Tresky Python template. That's fine. It'll be a private repository here. And continue. Don't need any of that other stuff here. All right, cool. So here's a link. So what I'm going to give you here rename this to labs, supposed to be lab 0. So labs are due the next week, 11:59 p.m. I usually do 10 points per lab because that makes life easy. Here, the points only matter within the category, right? Because the categories are weighted here. So please submit the URL of your repository. Repository. Include a screenshot of it running in the README file. I'll show you how to do that in a second here. Okay, so what we're going to do is we're going to please work with a partner to introduce them with Python code. Okay, not the most interesting bit of coding here, but it's to let you get to know a neighbor. Again, life is much better as a developer when you know somebody and work together with somebody else. It's real lonely to work by yourself, and you won't have as good of an output here because it's a very creative process. Generally, creative processes do better with more than one person, right? Because you can be creative together. Right. So we're just going to introduce them. It'll be there. Please print out the following name and preferred pronouns, their major, their hang on, I can't think at all. Name, major. What do they do when they aren't in school? So, do you work somewhere? Do you have hobbies? These sorts of things here. A fun fact about them, and the coolest thing they have seen technology do. So, not what you think it'll do in the future, but the coolest thing you've seen tech do. Okay. I asked this question to almost all my classes because I find it really interesting. There's all sorts of cool things tech can do. I came out of healthcare. Most of the cool things I think tech can do are healthcare related because I've seen a lot of healthcare related things. Um, some of the like virtual reality stuff is super cool. Beat Saber's a lot of fun. Right? If you like VR stuff, that's really cool. Beat Saber's an okay answer. Right? It's okay that fun tech is okay. Right? It's not. Don't feel bad. Um, those sorts of things. Okay. And we're going to turn in the URL and we can publish that. All right, so I'll take you through me doing it here, but I'll introduce myself and then you'll do it in lab. The reason is this is our practice. It's not a very interesting one, but it's okay. We want to make sure this GitHub workflow works because all of our projects will be submitted this way and all of our labs will be submitted this way. And if I can't see your code, I won't be able to grade it. And again, Canvas is a stupid place to put code. We're not going to put code in Canvas. We're going to use GitHub because that's a good place to put code. So you'll click the repository and it'll say, do you want to accept the assignment? Obviously, yes, because if we don't accept the assignment, we don't have a place to put our code. So we accept. Most of the time this works. It's been a little flaky lately, so if you get some sort of error after this, let me know. I just need your GitHub username and I can get it fixed. But it should work, so you should get a new repository. Hey, Chernesky, CIS 1501, fall 2025. Assignment, name, your username. So they're all going to be unique, which is nice. So I get mine for Lab 0 for Eric Chernesky. Okay, we get a README file. There's my main file. I thought I had one. Okay, I don't know what's going on with this one here, but that's okay. So a README file that shows us Python template. Not very exciting. We see the git ignore. Remember, this will tell Git, don't add anything that matches any of this stuff here. We don't need it here, which is okay. Just let that happen. And then a starter file. Actually, I kind of want to get rid of that. Yeah, let me go get rid of that real quick here. Sorry. Let me go delete it out of here. Delete file. Nope. Goodness gracious. Remember how to do this. Sorry, one second. Thought I could just delete right from here. That's fine. I'll go clone it and delete it and push that change. Just a second, sorry. So show an Explorer, we'll open it up here. I'll go delete that file. UI, good. Push that change, remove file, and push. And I got to go change my Python template too. Um, Python template so that it doesn't happen there as well. Give it 1 second, sorry. I'm gonna go change it here too. That'll make me happy. Show Explorer. Get that one. Nope, not that one. I want just Python template. There it goes. Main PY, delete. File. All right. Okay, one more. Now we're back to the lab. We'll go back to this one here. All right, so we're back here. Let me go. Now that I've cloned it, right, that just makes a copy of it on my computer. So I have my lab one assignment. Oh, that's the template. Shoot, I don't have it. I went too far. Sorry. Let me go back here. I'll just go back to Canvas here. I forget. So you can click the link again. It doesn't hurt anything if you click it more than once. Here's my repository. That's where I got distracted here. So it's got the main file. Don't worry about it. Yours shouldn't have it here. Oh, there we go. Sync. Let's sync. Sync. Okay. That'll remove it here. Now that my file's gone. Okay. Life is good. This is what yours should look like. So you get here. You got a ignore file and a readme file. You're going to click the green code button, say open with GitHub Desktop. And GitHub Desktop will say, hey, I want to make a copy of this repository. Here's the website for it. Here's where I'm going to put it on your computer. It defaults to this documents GitHub folder. I like defaults. You can put it anywhere you want. It does not matter at all. So I'm going to say clone. Now I have a folder on my computer that is a copy of the repository. And pick the second option for my own purposes. The first option can give you errors occasionally, so always pick for your own purposes. Now what I'm going to do is I'm going to make a project in this folder. Right? Can you restart the first step? So after you accept, you click on code, open with GitHub Desktop. Okay. We'll actually do this in lab once we get over to the HPEC building at 2. So we've copied it. Now what I like to do is I say show an explorer, and I click up here in this little white space, and it gives me the path, and I can copy that, which is nice and easy. Again, you don't have to do it this way, but I like my shortcuts. I'm going to copy that path. And over in PyCharm, I'm going to make a new project in that folder. So instead of this folder here, I'm going to paste in, or you can click Browse and go find it. I just happen to have a lot of repositories, so it's kind of annoying to go through my list. And we'll call this Lab 0. Right? Don't make a Git repository. Make your welcome script. Life is good. I'll say create. Okay. Should have a main file here, and then we're going to go in. For me, I'm just going to introduce myself because I'm boring here, right? Let's go through. So I'm going to print Eric Chinesky, he and him. I did that one. My major, print doctoral dropout. Almost all but dissertation here. I had like one class left here before I got to the dissertation. I ended up dropping it when we shifted online to COVID for stuff, and that I don't do well with online classes. What I do when I'm not in school, teach more and train for marathon. This coming October, I've not run enough here, so it'll be a lot of fun. This October, I run the Free Press Marathon almost every year. We go over the Ambassador Bridge, back through the tunnel. It's a great run, lots of fun. A fun fact about me here, what's a fun fact? I have 7 kids. Sometimes that's a fun fact. And the coolest thing I've seen tech do here, I think related to healthcare, I think some of the cool things around, now, not the AI tools being your doctor, but the AI tools helping your doctor not miss stuff here, like almost like a second opinion sort of thing. Medical records get to be complex, and there's lots of things that factor into it here. And there's a lot of things that you have to keep all in mind when you're making a diagnosis here. So it's nice to have a tool that kind of brings it all together for you here. Now, again, I'm not going to let AI be my only doctor, but I would like if my doctor used some tools here. So it's around like healthcare analytics, and diagnosis tools. A lot of cool things around imaging. So like radiologists will diagnose things from imaging. We've gotten really good with our tools at helping them find things to make sure they're not missing anything when they do diagnoses here. The sooner you catch cancers, the easier they are to treat, right? Which is really cool. So lots of fun stuff around that. The robotic surgery stuff is really cool. They just somebody did like surgery halfway across the globe for a patient. using robotic surgery tools. So you can have a specialist who's done this surgery dozens and dozens and dozens of times do your surgery. Turns out practice actually helps here. You want an experienced surgeon. You don't want a new surgeon, right? That sort of thing. So all sorts of cool stuff around technology here. Just going to give it a run. And it looks like it works, right? I got my output. Again, not very exciting. Oh, I missed a parentheses there. That's okay. Now to get your screenshot of it running for the README file, in Windows land, it's Windows Shift S all at the same time. Gives your screen snip tool. On Mac, there's another shortcut for it. I forget, it's like Command F4 or something like that. Shift Command 5? Okay, Shift Command 5. Because, sure, why not? And I'm just going to grab the output here. It doesn't have to be perfect. Now that's on my clipboard. So now I'll come back to the GitHub client here. Oh, I want to go back to the browser here. So I think I've got it. Is it this one? Wow, can you see that? No, it's just my computer freaking out. Uh, so I'm going to edit this README file here. You click the little pencil icon. This is my favorite way to do screenshots. And I'm going to go down a couple lines and just hit paste. And it will automatically upload it to GitHub somewhere for me and add in the image tag in my README file. I can say commit and commit. And now that screenshot will show in my README file when I look at my repository, right? So really nice and easy. You can throw screenshots in without having to do any extra manual work. There's ways to do it not this way. I just don't recommend it because it's not as easy. Okay. So now I come back to GitHub. It says, hey, there's a bunch of changes here. We can say lab 0 complete. Anything you want here is okay. I like good messages. I don't care what you put there. We'll commit and push. And it's going to yell at me and say, oh, it can't push because there's new commits. I changed it on the github.com website. So I have to go pull that change down first, right? It's a push and pull. Until I'm in sync with the cloud, I can't push my changes out there. So I'm going to go pull. It'll change the README file. And then I can push. So if you push first and then go change the README, it'll make life a little easier. You'll have one less click. That's okay. Either way works. All right. And now I can go back out to the website here. This is your sanity check. If you can see it on github.com, I'll be able to see it on github.com. So I go to lab 0. I'll go to my main file here. I see all my code. If you see everything you expect on the website and it's got my name on it, I'll be able to see it. Okay. That's how you know it's my repository because my name's on it here. Okay. I'll have access to it. So that's all we're doing for Lab 0. Get to know a partner, practice the GitHub workflow here. Nice and easy, soft start. Next week, we'll get to a more interesting lab, and we can go from there, right? So in about 20 minutes or so, we'll meet over in the HPEC building. You can even do it now if you'd like, but we got the lab time over there. Lab should be open for us. We'll hang out there. When you're done, you can leave. You don't need to ask me if you can leave, that sort of thing, and it won't be due until next week anyway. If you're just done for the day, it's okay. Questions, thoughts, concerns? Yeah.
When I joined the class, does it have the main PY?
I'm sorry?
Does it have the main PY file? Like when I joined
Oh, does it? Okay, you can just ignore it. It's fine. Yeah. Yeah. If you have a file already there in PyCharm and you make a project, it says you want to use the existing sources, is the other question it gives you, and that's fine. So removing it would save you a step, but if it's still there, that's okay. If it's not there, that's fine too. Should be good. All right, awesome. So I'll see you over in the lab in a little bit. Thanks, folks.